Welcome back. In this video, we're going to talk about how we categorize solutions as acidic, basic, or neutral. Even though we've looked at the ions themselves, chemists usually use a shorthand called the pH scale to describe these concentrations in a way that's much easier to communicate. In any solution, we have both hydrogen ions and hydroxide ions. If the amounts are exactly equal, like in pure water, the solution is neutral. If you add an acid, the H plus concentration increases and becomes larger than the OH minus, making the solution acidic. Conversely, if there's more hydroxide than hydrogen ion, it's basic. And remember our golden rule. As one goes up, the other must go down to keep that product locked at 10 to the negative 14. To make these tiny concentrations easier to handle, we use the pH scale. The letters pH literally stand for the power of the hydrogen ion. Mathematically, it's the negative logarithm of the hydrogen ion concentration, but you don't need a calculator to understand it. It's really just a way to turn those awkward exponents, like 10 to the negative 7, into simple whole numbers like 7. Calculating pH is actually very straightforward if you use the exponent trick. If your hydrogen ion concentration is 1 times 10 to the negative 3, you just look at that exponent, ignore the negative sign, and there's your answer, 3. If the concentration is 10 to the negative 12, the pH is 12. It's a quick way to see exactly where a substance sits on the scale without needing to do any complex math. The scale centers at 7, which is neutral. Anything with a pH lower than 7 is acidic, so a pH of 2 is much more acidic than a pH of 5. On the other side, anything with a pH higher than 7 is basic, which we sometimes also call alkaline. That's why a high pH of 13 represents a very strong base. To give you some perspective, your stomach's gastric acid is very acidic, with a pH around 1 or 2. Sodas and vinegars usually sit around pH 3. Moving to the basic side, common household ammonia is around pH 11, and heavy-duty drain cleaners like lye are at the very top of the scale at pH 14. Now that we understand the scale, our next video will look at how we actually measure these values in the lab.